Hi there, it's Advancing Data Science Capstone project for IBM Coursera. Here's my project on GitHub. First of all, we can explore its Jupyter notebook. It's provided for data preparation, analysis, and creation model. First of all, I have decided to investigate human measurement, and the very first task is to build classifiers that can predict human sex based on its measurements. So, first of all, we have to find available public data, but if we can find it, we can find web resources that contain all needed public data, write on parser and get needed data. We can save it to CSV file, and for the next runs of notebook we can use prepared CSV file in order to speed up, and we don't have anymore to load all the data over web. Here we can explore this data for basic measurements. As we can see, there are a lot of outliers, so we can write a filter for the data and leave only data that can be met in reality. So after all, we can see that the data now looks pretty good. We can see scatter plot for example, for waist and hips. We can see here two clusters, but actually second cluster it's not a data, it's an outliers, and it's data inputted by mistake, because waist is here bigger than hips, that actually cannot be, so we can write additional filter, get rid of those data, and now we have clean data. So after all, we can build a box plot to see if there is an outliers. We can divide box plot by sex, for example, for age. There are not so many outliers for weight, height, and so on. And here measurements as breast, waist, and hips for male and female, and his human shape, as we can see. And after all, we can plot scatter plot for every pair of parameters, and here we can see what really we have, and we can analyze that distribution for different groups not the same, and this means that we can build classifier over these parameters. So moreover, we can plot correlation matrix to investigate whether the data depends of different axes. For instance, we can see that human height doesn't depend of its age, and for men and female actually a little bit different correlations. Here we can explore additional dependency, for example, weight grows over age for male and female a little bit differently, and we can notice that weights depend on human height. Here we can express the same box scatter plot with more information, dependencies over sex and human age. And after all, we have data prepared, and now we want to build models that can. Now we can build neural network that can predict all we need. We use Keras framework with TensorFlow as backend. Here we can write helper functions. Here we can create two-layer model with two final layers and output layer which make predictions, and input layer with 6 dimensions, as we have 6 parameters. First of all, we prepare the data, split it in train and test set. I have to mention we have a data set for about 20,000 persons. First of all, we can compute confusion matrix for different parameters. As a parameters, we can find different number of dimensions for hidden layers, and we can express it on scatter plot where one point is false positive and false negative predictions, and we can choose parameters for network which provide the minimum wrong number of wrong predictions. Here matrix for false negative or false positive values. Here number of dimensions for first layer and number of inputs for the second layer, and we can find out that for certain configurations there is certain configurations that can't predict data at all, and here the same for false negative predictions. We can find some predictions are pretty good. Although we can express complex values that count as negative, as false positive values, and here we can choose the most suitable architecture of neural network, and here we can find that 6 neuron in first final layer and 9 neuron for second layer provide the best result. After all, we can find the most suitable activation functions for hidden layer. I consider relu, linear, and sigmoid activation functions. We can see that sigmoid activation is not so good, but relu provides the best results, and here we define activation functions for hidden layers, and now we got final model. We can see have input layer for 6 dimensions, hidden layer with 6 neurons, next with 9, and output layer, it's about 100 parameters. We can train with trained data, we can capture loss function over time. Over time we can see it's converged pretty fast, and as a result we can print out confusion matrix, and as you can see we have pretty good estimation because false positive and false negative results are within 1%. So after all, we can combine obtained result with test data set, and we can prepare and after all we can plot scatter plot for each data and express true positive, true negative, false positive, false negative data. As you can see, false predicted data are somewhere between, and as we can see, true predicted data have different distributions, and false predicted data have distributions somewhere between. It means for distribution interception we actually can't predict the data. That means that's why our classifier can't predict extremely well. So as a result, we have prepared classifier models, and we export the model for further usage. It's first stage of investigation. We have analyzed the data and prepared classification model ready for deployment. The next stage is we can build REST API that uses our model, so we can run Jupyter notebook. It's save initial data set, and also it save a model. After all, we can build API ready for production. We can we have instruction how to run it. So first of all, we have requirements. Flask is framework to to build web application, REST Plus extension that's all to build REST API with Swagger documentation, and here we use Keras framework and TensorFlow for usage neural network model. Here we have actual requirements. We can build the project. First of all, we have to create virtual environment, then activate it, then install requirements over web tools, and then run that application. Here we can have the code. We describe input data. We describe web address. We get data, prepare it, pass to a model, and get the result. Here we can run it and check what we have. Now it's now we can run and check the results. It's starting, and it's a little bit slow because of debugging mode. Now it started. Here we use Swagger documentation. It describes output data. It's described all available APIs. Here we can input the data. For example, let's check here the first prediction, and let's say another prediction. It's pretty obvious. So we have API that can be deployed anywhere, and we can check it, and everyone can use it. Later it can be updated with additional classifications and regressions. That's all for now.